The second one is given as what? S, which equals ut plus what? Half at squared. The third one is given as v equals u plus what? At. While the last one is v squared equals u squared plus 2as. These are the four good equations of motion. They are very, very important. You have to know them and make sure you swallow them. Now, what are their parameters? What are the parameters involved? Your u, let's start from this. Your s here signifies your distance covered, or yes, say distance measured in meter. Your v signifies your final velocity. Your final velocity. While your u is the initial velocity. What else do you have there? We have your a. The a stands for your what? Acceleration. All these velocities are measured in meter per seconds, whether it's initial or final. Acceleration is measured in meter per second squared. What else do you have there? T. Your t is just your time taken. So it's measured in what? Seconds. So I think those are the parameters involved that have been put together to form the four equations of motion. So they are very easy to assimilate. That's very easy to swallow. Just have them at the back of your mind so that when you eventually get to that particular topic in physics, I think it will be in SS2 level. You'll be able to use them constructively. So now let's go to the actual professional difference, or the differences between speed and velocity. There are two different things, speed and velocity. Now we're looking at the two differences between speed and velocity. Number one, from our slide, we'll be able to realize that speed depends on the path taken. Are we saying it? The first point is that speed depends on the path you are taking, while velocity is independent of your path. Meaning that irrespective of the path you face, irrespective of the path a body faces, do you understand? The speed can always be obtained. But velocity it depends on the path. Why velocity is independent of the path, meaning that speed depends on that path. You see, if I'm going to, let me say, if a body is facing direction A, I want to put it in a practical form now. If a body is going to direction A, the direction which that body goes to will determine the speed of that body. But for velocity, irrespective of the direction the body takes, either diagonally, upward, downward, backward, forward, do you understand? The velocity can be obtained. Are we getting it? So speed depends only on the path taken, while velocity does not depend on any path taken. Now speed is always positive. What am I saying? The values for speed, that's your second point now. Speed will always give you a positive value. Anywhere in physics or any topic in physics where you calculate your speed and you are getting a negative value, then there is something wrong. But for your velocity can come out negative or positive. Velocity can come out negative or positive. That's another word, full meaning. Differences between speed and velocity. The third one is speed is a scalar quantity. Yes, speed is always a scalar quantity. If we go through the initial topic we started with scalar and vector quantity. So if you go to examples of scalar quantities, you see speed. When we go to examples of what? Vector quantities. Examples of vector quantities, you see what? Velocity. Now the fourth point is that no dependence on direction, and so is only positive, which we have said the other time. Now the fourth one, the first point for velocity says direction can be guessed from the what? Sign. Are we getting it? The sign which a particular value gives you will determine the particular value's direction. What am I saying? If I'm given, let's say, a plane runs with a velocity of minus 50 meters per second. Now this minus signifies that it could mean that plane is running backward. Are we saying the plane might not be going forward as what? Extreme, but it can be running backward. So it means that irrespective of the path the plane takes, the plane is still undergoing velocity. Are you getting it? So additionally, an object can make a round trip, now travels away from the starting point and then returns to the same position at zero velocity, but travels a non-zero speed. What are we saying? It can go around and then an object can leave a particular position, goes around and then come back to that position. It means that it has what? It has zero velocity. But an object can never have zero speed. Are we getting it now? So those are the little analysis when it comes to speed and velocity. So we said, what are the tools can you use to measure your speed, displacement, velocity, distance? You know, we have the mini tools. They are what we call mini tools. So it's inside your mathematical set. Mathematical set. You know, what you normally call your math set. Now, in that mathematical set, we have what we call your divider. Number one, you have the divider, something like this, but it's definitely in your slide. Now, we have what we call your protractor. Your protractor. Now, that one goes this way. Right? Now, we have the third one. We have what we call your compass. You understand? We have the fourth one. We have what we call set squares. Call it set squares. Set squares. Now, some could come this way. You know, some could. They are actually two. Now, this one is actually used to measure. There's what we call scaling. Scaling type of what? Angles. Why this particular one will be used to measure, not talk of isosceles or something, but they all have their what? Their mode of what? Usage. Of course, you know what your compass is used for, to construct your circle. Your protractor is always being used to what? To measure angles. You understand? It's being calibrated like this from 0 to 90. 90 to 180, then from 0 again to 90, then 90 to 180. So irrespective of how you use it. Then you have some other things, your pencil, your ruler. We have the fifth one, the ruler. You know what the ruler is used for, to measure distances. So you have to get used with all this. You have to know their uses so that when you get to the exam, each time you are dealing with any particular issue on speed and velocity. Speed measurement, speed time graph, how to what? Okay, now another good thing came to my mind. Now, when you are measuring your speed, you know, with respect to a graph given to you. Now I told you that for you to actually calculate your slope, for you to actually do your prediction as we mentioned earlier, you have to put it on the graph, on the graph book. Now, on your graph book, all this will be very, very, very much important. I mean, it will be very much useful. You have to know all their uses. Of course, you know you need your what? Your eraser. In case you have what? Errors. You need to what? Rub things up. And sharpener. So these are the major tools you need when it comes to your what? Your speed, velocity, time measurement. Now, on a chart there, you can see different chart. You have the first one which speaks about the velocity time graph. Now, that first one analysis, look at. You need to go back there so that you know what they actually meant. Now, something like this, it goes this way. You have a graph that goes this way. I love that graph so that I'm trying to explain that graph so that you don't get confused. Now, what kind of graph is this? Now, you have something like this. Another one goes straight. Now, another one now goes downward and upward again. Now, what type of a graph is this? It means that the vehicle started accelerating here. When I say accelerating, is increasing in speed upward with respect to time. Now, they now have a constant speed here. It's like a vehicle. When you first start the vehicle, you were hitting it up and trying to make sure it's running higher speed, 100 kilometer, 120, 140. You understand? Now, you now get to a point that you are now maintaining, let's say, 80. You understand? Suddenly, you just decide to decelerate. Maybe you match your brake or something for it to go down. Before the vehicle goes off again, you put leg on your accelerator again. The car started speeding. Do you understand? So that is what is actually happening here. Here is what we call deceleration. Deceleration is for a vehicle to slow down. Now, increasing acceleration. Hope you are saying it. So all this explains the first graph. Now, of course, you know we have the second one, which I've explained initially, with graphs of motion. The first one talks about graph of what? Motion when you have at constant speed. The second one talks about when you have a positive slope. The third one is the negative slope. The fourth one is what we call in sciences we call it adiabatic slope. You understand? But don't worry, it's still higher than in level. When you go higher, you will be able to see it. Now the last one talks about your normal velocity time graph. It's still the positive slope. So if you go through it, velocity time graph showing an object with constant acceleration. So this is the positive slope, it's your constant acceleration. Now, as regards the topics, as regards the question, number one here says that which of the following physical quantity is not a derived quantity? Remember, we dealt with the difference between physical and derived. So we are going to solve that question now. Because for every question you need to solve, you have to understand the actual basis, the place as in the point where the question is coming from. Now, the first one, what are derived and what are fundamental? If you recall, we said fundamental quantity are quantities that can stay alone. So looking at that question, you realize that they have option A, area, option B, they have the thrust, option C, pressure, and option D, mass. The question is which of the following units is a physical quantity and not a derived quantity? The best answer there is your mass. Number D is the best answer. So let's go to number 2. Number 2 says which of the following is a fundamental unit? He said they are fundamental quantity